Hey everybody, I wanted to provide you with a solution to the problem we were working in class today with the circus performer shooting through the air and flying past our window. And I wanted to also just kind of review the kinematic equations again, so hopefully this will be a helpful video. So just pointing out that these kinematic equations we talked about are only for cases where the acceleration is constant. And so a lot of the constant acceleration problems that you'll see are, a free fall object, right? It's where an object is flying through the air on Earth and Earth's gravity is 9.81 meters per second downwards. So, if you're in a kind of projectile motion situation where you have a projectile flying through the air, you're probably in a constant acceleration problem, and you can probably use these kinematic equations. All right, so the position as a function of time is equal to the initial position plus the initial velocity times time plus 1/2 the acceleration times time squared. So the position could be like the x position, but you could just as easily write this equation as the y position, and then you need to be thinking about, if the velocity is going in the y direction and the acceleration is going in the y direction. So this will come up later when we switch to motion in 2 dimensions. All right, and then we know we can get the velocity at a given time by taking the initial velocity and adding the acceleration times time. But what if you get a problem where you don't have information about time, but you have information about the velocities, changing with distance. So we can combine these two equations to derive a third kind of convenient kinematic equation. And I'll show you how we're going to do that. Okay, so what we're going to do is we're going to start with equation number 2, and we're going to rearrange it to solve for time, right? So we subtract v naught from both sides. So v naught has now been moved over to this side. And then we're going to divide by the acceleration. All right, so now we've expressed time is going to be equal to our velocity minus our initial velocity divided by our acceleration. And then what we're going to do is we're going to plug in time here into time on equation 1. So we're substituting in this into equation 1, right? So we have x plus x naught times v naught. This used to be time. Now this is our expression for time, plus 1/2 a times time squared. This is time squared, right? And then we just kind of do a little bit of algebra, and you can, follow along with this if you want, but essentially some terms combine, some terms cancel, and in the end, we can get a simple expression where we can calculate what is the velocity at a given time as a function of the initial velocity, the acceleration, and the change in position. So this is kind of third kinematic equation, v squared, velocity at a certain position squared is going to equal the initial velocity squared plus 2 times the acceleration times the position minus the initial position. And sometimes this x minus x naught is written as delta x, like what's the change in x. All right, so let's jump back to the in-class example now, where we have our adventurous street performer shot up through a cannon, and we're up on top of the office building on the 4th floor, 15 meters up, and we see the street performer fly past the window going 3.2 meters per second. And the question asks 2 things. It asks how long ago did the performer shoot out of the cannon, and how long until they hit the ground again. All right. So a lot of people, they kind of want what's like the cheat code for the class? Like, is there like a formula that we can always use? And there really isn't a formula you can always use. you kind of have to use your head a little bit to figure out what's the right thing to do. But I would say that for almost every physics problem we do in this class, you can kind of follow this universal game plan. And I know it might seem a little obvious, but these are some really helpful tips that I think if you follow, you'll kind of learn to approach physics in the right way. So the first time, anytime you have a problem, you want to draw a picture, right? And you want to label the picture. You want to label the variables in the picture, and you want to choose a coordinate system and place that coordinate system on your picture. All right, after that, you want to write out a list of the knowns and the unknown variables. You want to, only after you've done that, do you want to kind of think about the appropriate equations or techniques to solve for your unknowns. And then you begin solving. You might need to solve for like an intermediate variable that the question doesn't ask about. Or in the end, you might need to combine two or more equations using kind of substitution if needed. We're not going to need that in this problem, as I'll show you. All right, so here's my step 1 and 2. I kind of drew a cannon, and here's the Circus Performer flying past, and note that I'm labeling the velocity that he's flying past. And I'm also kind of introducing two new times. So there's time 0 is like when the cannon gets launched, and time 1 I'm saying is when we're flying past the window. And then it's also asking how long it takes for the guy to hit the ground again. So I'm labeling the time that he hits the ground again as time 2. And I've drawn my coordinate system specifying that y equals 0 is the ground, and that positive y is going in the upwards direction. Okay, now we want to start thinking about the knowns and unknowns. So what's the initial position of the guy shot out of the cannon? Well, he starts on the ground, so it's 0. And what's his position when he's flying past our window at time 1? It'd be 15 meters. And what is his position when he hits the ground again at time 2? It'd be 0 meters, right? Okay. And we also know that when he's flying past our window, his velocity is 3.2 meters per second. And we know this is a free fall problem. So acceleration is negative 9.81, and acceleration is negative because gravity is pointing down, and we said up is positive. So therefore gravitational acceleration is negative. Okay, so the unknowns in the problem is how fast was he going when he left the cannon? And then the two things that the problem actually asks about is how long ago the Circus Performer shot out of the cannon and how long until they hit the ground again. So we kind of need to know time 1 and time 2. So you can see we kind of have, we have a velocity unknown and we have a time unknown. So now we do step 4. We want to find appropriate equations to help solve this, right? So and this is kind of a key aspect. Which equations should we choose? We have 3 different kinematic equations to choose from. So when evaluating the kinematic equations and deciding which one to use, the thing I suggest you do is count how many knowns and unknowns are in each equation. So for instance, with equation 1 here for position, we said we don't know time, so that's one unknown, and we don't know the initial velocity. So this equation contains 2 unknowns, which means we won't be able to solve it by itself. All right, how about this one? Well, we do know the velocity that he's flying past the window at, but we still don't know the initial velocity, and we still don't know the time. So this equation still has 2 unknowns. So let's take a look at our third one. Well, this one is the velocity that he's flying past the window at. We do know that, okay, but we don't know the initial velocity. But hey, this third kinematic equation doesn't have time, right? And so, x, or in our case, y, that's the height of the window above the ground, and the initial position we know. So if we count the number of knowns and unknowns in this, there's only one unknown in this equation. So we can use this to solve for the initial velocity. And then after we know the initial velocity, that can be a known, and then there would only be one unknown in this equation. Okay, so let's do that. All right, so we're going to solve for the initial velocity. And there's a few different methods for when you're doing physics. Some people like to plug in numbers right away, and you could do that if you want. It's kind of up to you. I think it's kind of neater and cleaner to, before you plug in numbers, to rearrange the equation to what you want to solve for. All right, so what we're going to do here is we start with this kinematic equation. We're going to move this to the other side by subtracting. All right, and then we're going to take the square root because we want to find v naught, so we take the square root. And now that I've solved for the variable on one side of the equation that I'm interested in finding, now I'm going to plug in numbers. So 3.2 meters squared minus 2 times negative 9.8 times 15 meters. And we're going to find that the initial velocity is 17.4 meters per second. Okay, now I think we can try and solve for one at a time. So let's solve for t1. So which equation should we use to solve for t1? Well, we could use this first equation because now we know the initial velocity and there's only one unknown in this equation, time. Well, if we could definitely use this one, but if we did, we'd probably have to use the quadratic equation. And you should know how to be able to do that. But it might just be easier to use equation 2. So we have options here, right? Because now we know the initial velocity, we know the velocity that is flying past at, we could just solve for time that way. That sounds easy. Let's do that. All right, so v at a certain time is going to equal the initial velocity plus a times time. I'm going to rearrange this equation to solve for time, subtracting v naught and then dividing by acceleration. So we have 3.2 minus 7.4 divided by negative 9.8. And we see that it took 1.45 seconds from the time of the cannon blast for the Circus Performer to fly past our window. And now we're asked to solve for t2. So which equation should we use? Well, we know that when the Circus Performer hits the ground again, that their final position is 0. And we know their initial position is 0, so let's use this equation because it describes how position is changing. Okay, so we know that, their final position is on the ground, so 0. Their initial position is on the ground. We know the initial velocity, and I'll plug in time 2 here for time, 1/2 acceleration. So let's rearrange this equation. We're going to subtract v naught times t and put it on the other side. And we have v naught times t equals 1/2 times acceleration times t2 squared. Well, we have t on both sides. We can divide both sides by t, and t is going to cancel on this side, and then we no longer have t squared on that side. And then we can go ahead and solve for t. Multiply by 2 and divide by acceleration. So t2 is going to equal negative times the initial velocity divided by the acceleration. So that's going to end up being 3.55 seconds. But if we wanted to be precise and double check the question, what the question's asking is how long until they hit the ground again, right? And what we've actually measured, because in this problem, I kind of set a reference frame not only for the position, but also for time. I said time equals 0 is when the cannon was fired, right? So this final time I found is in reference to when the cannon was fired, right? So if we actually wanted to solve for how long until the Circus Performer hits the ground again, we would just subtract 3.55, subtract 1.45 from 3.55, right? So we can say time from flying up past window to hitting ground that is going to equal 3.55 minus 1.45, 2.1 seconds. All right, and now we've solved our problem. So I would encourage you to, when you're reviewing videos like this, to, not necessarily like think that the way we solve a specific problem is going to be the exact way we solve other problems, right? We might get another problem that, maybe using this equation first wouldn't make any sense at all, right? It depends on the problem, right? Follow this universal game plan on almost every physics problem we do, and you should be okay. And this key step of finding the appropriate equation to use, right? You want to understand what kind of problem you're dealing with, if it's a force problem, if it's a vector problem, if there's more than one dimension, if it's, what kind of problem it is, and then that can direct you to the type of equation you want to use. And specifically, after you've counted the knowns and unknowns, when you're really looking for the right equation to use, you might look at individual equations and say, wait, how many unknowns are in an exact equation? And in some cases, when we proceed further along, you're definitely going to need to do this second technique of, if you have two unknowns and two equations, you're going to need to use substitution in order to get a final solution. But anyways, hopefully that's a useful video. Sorry for making it a little long. But I'll send you some other resources and tips your way soon. And yeah, have a good day. I'll see you Friday.